This video will walk you through testing assumption 1. The assumption in number 1 is that the expected value of all of the residuals is equal to 0. Now remember, OLS forces the mean of the residuals to be equal to 0. So what we're actually testing here is whether or not a linear relationship is appropriate. And we're just going to do this using a visual method by looking at a plot of the standardized residuals and trying to make sure that we don't in fact see a pattern. If we do see a pattern, then it means a linear model isn't exactly correct and we should go back and perform a transformation like we learned in chapter 5. So I'm looking at this Telemark data set that I also saw in chapter 5. And remember, this is a relationship between the number of months you've been on the job and the number of calls a telemarketer makes. So your X variable, your independent variable is months, and the dependent variable is calls. And I can just go in here really quickly and highlight this and insert a scatter plot, and we see, as we've seen before, that as you've been on the job longer, your number of calls increases, but at a decreasing rate over time. So that's, the relationship that I know and I've seen before. So I'll just put that up here as a reference point. Now, let's say I want to confirm, in this case I happen to know that quadratic transformation was actually the appropriate methodology for this. But let's confirm that idea by looking at the standardized residuals of our regular linear regression, and we'll actually see that there is a pattern. So I would just go in and run a regular regression. So data analysis, scroll down to regression, select OK. My my Y range is calls, and my X range is months. I have my labels in there. I want 95% confidence. I want my output on any open cell here. And I'm going to select standardized residuals. Now, standardized residuals are just going to standardize them between roughly between 0 and 4 in the positive and negative range. It just makes it, common so that you're always looking at numbers in the same region. And the way it does this is it uses the standard error of each of the residuals in order to standardize them. Okay, so I will click OK. And I get my output here, as I've seen before. We've already gone over this example a couple of times. I'll just neaten it up here a little so we can see our residual information. Okay, residuals and standardized residuals. Now, let's say I want to do my residual plot. So let me insert a column here. Let's look at my months as my X variable and my standardized residuals as my Y variable. So I'll copy them up here. Oh, let's make sure I get all of them. Hold on. Copy them up here. Okay. Paste that in there, and now I can create another scatter plot to look at that. Insert scatter plot. And I can see that, there is a definite pattern here. Remember, I should be seeing random variations around 0, but that is not what I'm seeing. I'm definitely seeing that same kind of quadratic relationship, which is suggesting that, the way to fix the violation of this assumption would be to go in and do the quadratic transformation. Now let me show you the same example in SPSS. I can bring that up again, and to start out I can make my regular plot, not histogram, sorry. Go into graphs, scatter plot, simple scatter plot, and click define. Months is my X and calls is my Y. Click OK. And I see that same quadratic relationship that I saw earlier. Now I can go into Analyze and perform my regular regression. I'm just going to do my linear regression where my dependent variable is calls and my independent variable is months. I'm going to select Save, and under Save I'm going to select my standardized residuals, and then I will click Continue. Under Plots, now, no, not going to, well, under Plots I can do a histogram of my standardized residuals, and that'll help me to see any outliers that I have, and we'll discuss that when we're testing another assumption in a different video. So I can click OK, and it's going to run my general regression for me. But then to get, and it'll show me my histogram of my standardized residuals, and you can see none of these seem to exert too much leverage. Again, that's something we'll discuss later, but your standardized residuals tend to be falling between 2 and -2 with a rather small standard deviation. But if I go back into my data editor, I now have this standardized residuals, Z-red. It gives me my standardized residuals. So now I can go into Graphs, Scatter Plot, and I can graph with my standardized residuals as my y-axis and click OK. And now I'll get that same, basic plot that I saw over in Excel. And what's interesting here, I can edit this in a variety of different ways. So we know it's supposed to be clumped, have no random pattern around 0. I can go in here and I can put in a line, let's see, put in a line at 0. All right, so I can see that, I am in fact seeing a pattern there. And so I would say that this is a clear violation of assumption number 1.